Architect. Yeah, I'm down here at our forever home. We got Shoreline builders, framers, trusses. We even got this beautiful little lull that, yeah, I'm gonna confess, I jumped in here and thought I was gonna take it for a little bit of ride, maybe help out, but obviously there's some adult supervision here because I don't have no stinking keys. So we're definitely not taking this for a ride, but I guess what we need to do is we need to jump out and talk about roof framing. Yeah, that's what this episode is all about. We got roof trusses going up here. We got a bunch of little tidbits of information that I think you're going to find very interesting. So let's head on over and talk roof trusses.
Forever Home, a Build Original series, is brought to you by Builders First Source, Baczek Exteriors, Huber Engineered Woods, and Rockwool. Forever Home, a Build Original series.
Hey there, Build Show. Steve Baczek, Architect. I'm out on the site of our forever home. You can see behind me here, you might notice we have a bunch of interior walls framed, right? I can pull them off here. You can see there's a couple small ones here, larger ones here, but guess what you don't see? You don't see scrap pieces. You don't see sawdust. You don't see a mess. You don't see a pile of waste. That's because we chose to use the Ready Frame project out here. The Ready Frame is a package that basically comes out, and it comes out all pre-cut. You'll notice all of the positions are digitally printed on the top plate and bottom plate. So it's literally all spelled out for you. And the beauty of this is the guys were framing the wall framing here for, I don't know, 3 or 4 days. They never had to break out a saw. We're pretty much almost through roof framing, and we're getting rid of the very first 10-yard dumpster. So there's little to no waste out here. It's pretty much a no-brainer. And all of the interior walls, the same thing. Exterior walls, all of the headers are pre-cut, all of the LVLs. They did our pocket headers the way we would typically do them. So everything was to the way that I intended it to be done. It was done with the accuracy and expertise that we would expect, and everybody that was a part of the process found it very favorable. So give BFS a chance, give that Ready Frame package a chance. Get with your framers, try it out once. It is certainly not over the top, and like Jim and Shoreline and their framer Ryan, you might be pleasantly surprised that Ready Frame is the way to go in the future. All right, so no keys to the lull. That means I gotta talk. Yeah, so roof trusses. I don't know if you're familiar with them. I don't know if your roofs are mostly what we would term a cut roof, or you're doing 2x10s, 2x12s. Some parts in the country, you know, Texas, they do a lot of 2x8 roof framing just because they don't have the snow loads and such that we have here. On this particular house, we had some pretty large spans, probably upwards of 30, 32 feet. And when it starts getting up there, it becomes a question of, do we maybe switch to a roof truss? Because it might be a little bit easier to set these. And what's really interesting is one of the framers, you know, he confessed this is his first time ever doing roof trusses. He found it very favorable, but maybe we can catch up with him and get some thoughts. But before any of that happens, I wanted to talk about roof trusses in general for those that aren't familiar with it. So you can see here, a roof truss is nothing more than a pre-manufactured structural system that basically holds up the roof. It's comprised of this long board that goes across the bottom here is what we would term the bottom chord. The sloped one that goes up the top here, we would term that the top chord. These members inside here, these are simply web members. And then down here, we have a little specialty piece. So there's a lot of names for it, but the truss guys that I have dealt with in the past, they like to call it a slider. And what a slider is is it is basically this 2x6 that slides down into this joint. Now, why would it slide down into the joint? We're in climate zone 5 here. We have some elevated values in ceiling R value. I think here we're probably somewhere in like a high R70s, I think, for this project. So we want to get that heel height pretty high, and here I think we went with 10 inches, and the heel height is on the outside of the wall here. It's the distance from the top plate to a vertical projection there, so that's in fact 10 inches. So you can see we have the bottom chord 3.5. We have this on a plumb cut that, even though it's 3.5, this is probably like 3 3/4. So we have to make up that difference of, say, I don't know, what is it, like 2.5 inches or so, and that's where this slider comes in. You can see it comes down, it gets cut horizontally, and then it has a plumb cut here that's cut to match that bottom chord, and it basically just slides in. But what it's doing is it's separating the top chord from the bottom chord to provide that 10-inch heel height. And the last part of the trusses, you can see there's all of these metal plates, and these are just simple truss plates. They're I don't think we have one here, but they're heavily toothed, like dangerously toothed there. So these all get made on a table, these get set on it, and then they get clamped. So this one actually has a twin on this side. Everything that you see in plating here has a twin on the back side. So it's basically making that structural connection between the top chord and the slider here, and the slider and the bottom chord. This one's catching part of the top chord. When you come to the web members here, that's what connects the web member to the top chord, web member to the bottom chord, etc. And you know, trusses are probably one of the most efficient structural members out there. And the reason for that is, obviously you can see this truss stands maybe 10 foot tall. I want to say it's probably 28 feet long, but only about 10% of the actual truss is wood framing. There's a lot of air and void here. So it goes through engineering, and the engineering comes in and says, okay, we need this one at this angle cut, and then these plates have different sizes to it. So there's a few different trusses on here. Occasionally you'll see a girder truss go up, and we'll be able to point that out inside, and you'll immediately notice all of these metal plates are probably twice the size. All of the chord members, bottom chord, top chord, are elevated to a larger member there. And so that's basically the anatomy of a roof truss. You know, down here we have our roof overhang. So the way that I like to do it is we have a 24-inch overhang, but that 24-inch overhang includes a 2x6 rough fascia. So it really means that our end cut is 22.5 inches. But I don't let the truss company know that, because over the 32 feet, the fact that these are pre-manufactured, sometimes there might be a variation of 1/8 of an inch, 1/4 of an inch. So what I do is I call for the truss company to make this a clear 24-inch horizontal projection. And then when they get up and installed, the builder will simply snap a line at the 22.5 inches, and then he'll rip individually each of the little bit of tail off of that truss tail. But what that'll do is, in the end, that'll give us that perfect alignment of all the trusses and kind of give that custom fit on site to a pre-manufactured product that was made off-site. So why don't we head inside? There's, I don't know, maybe 4 or 5 areas that are really kind of key points to the roof framing here, other than, say, the standard common truss that I'd love to review with you. So I'll see you on the inside. All right, well, we made it inside. I know, eventually. You know, the things about construction is I can walk around and pretty much stop at every corner, nook and cranny, and probably talk for about 30 minutes. So a lot of things are going through my head when I'm shooting these videos, but I'm trying to bring you things that maybe you haven't seen, or maybe you need to understand a little, or that relate to a comment from a previous video, or going to make a difference in understanding what is to come, how we plan for that. So anyways, we're inside. I'm inside the main space. Basically, the kitchen is here, dining room to my left, and I'm looking forward into the living room. So giant great room here, right? If you remember episode 1, I walked through the plans. If you didn't watch it, go back and watch it. If you want to understand this, I grabbed my big red stick. If you didn't know, yes, I have a big red stick. It allows me to point up high without needing a ladder. So we're inside, kitchen, dining, living room space. Pretty easy to show you. These are pretty much the common trusses. These are the ones that we talked about when I talked about the anatomy of a truss. The bottom chord here, you can see the web members, the metal plates. These are giant beams. They're just triangularly oriented rather than square or rectangle, but they do the same work as a floor joist, as a floor beam, as a steel beam, as a concrete beam. These are just made out of wood, and they just happen to be a triangle. But make no mistake, structurally, they're nothing more than a beam. As these cords come in and out, those joints are receiving tension and compression loads at each one of the joints, and they're coming in and they're leaving there in an equal, say, amplitude. And the reason for that is that's how things stand up, right? If the load comes in heavier than you can resolve it for, that's how things break, right? The beam isn't strong enough to carry it. So the load comes into that joint. The joint is designed to carry that load successfully, and that's why buildings stand up, right? I know it seems fundamental, but it's amazing how much some people don't quite understand the building industry, and they're intrigued, and I always try and take us back to square one. So this here will be a standard flat ceiling here, so notice the trusses, but notice what we have at the end here, right? Here we have a piece of MyVest. Now, this is MyVest 200. It isn't a self-adhered product. This is just a membrane product, and they happen to have the roll right here. So MyVest, M-A-J-V-E-S-T. This is a SIGA product, and it is a membrane. It is highly durable. You're not puncturing it. It's a weather-resistive barrier typically, but it has very good air properties. And I'm going to embarrass myself here because, whenever I tell people, hey, that's an air barrier, and they say, well, it really isn't. I say, okay, put your lips up to blow on it. I'm going to prove to you that it's an air barrier, all right? Yeah, no air goes through it. I cannot blow through it. It is an effective air barrier. So what is happening is we're taking this MyVest, and if this is the top plate up there, it's actually a 2x6. We're just draping this over. And as we drape it over, we put the roof trusses, sit them on top of that. Now, what is that doing for us? Well, what it does for us is on the wall, we have our zip system R6. That is not only our integrated weather resistive barrier, but that is also what I would term our primary air barrier. That goes all the way up to the top plate. The MyVest drapes over that top plate. It'll get taped on the outside to the face of the zip, making that air barrier connection. That air barrier connection will go up over the top plate and result in this little flap here. The trusses will then get set on top of it, but here you can see the truss sits on top of it, and if I hold that up, that gives me about a 4-inch flap to then run our MyRex, also by SIGA, smart vapor retarder, but also an exceptional air barrier, and we'll run that membrane across the ceiling. If you're familiar with my videos, you probably have seen it, but that'll run. So now our air barrier is going up the foundation wall, makes the connection to the zip R9, or R6, zip R6 connects to the MyVest. MyVest laps over, MyVest connects to the MyRex, goes across the building and down the other side. So there you have it. Moving over here, we're going to see a little different truss. So you can see we have what we would term our common trusses here, right? These are our flat ceiling trusses. They come across, but notice at the end of this one, we have another truss directly inside of it here. And that truss inside, notice it has a 10-inch recess and then flies across as a flat ceiling. And that 10-inch recess continues all the way down to the same double truss here. And then it drops down to the 9-foot height and we'll have our soffit. What that's doing is it's giving us a 10-inch recess with a perimeter soffit around it, but we will then come in and we'll finish that with a coffered ceiling. Now, why are we doing it just in this space? If you remember in episode 1, when I talked about the 3 spaces, kitchen, dining, and living room, the kitchen was going to receive the simple flat ceiling. The dining room, we were going to do some kind of drop ceiling to accentuate that dining room as a space within the larger space. And then of course here we have our living room with our TV wall. So we wanted to do something here. The beauty of trusses are I can carve into the trusses here. The truss company will do the engineering and the slight modifications. You can see there's just a larger plate, there's some vertical members, there's a little diagonal web member there, but basically they resolve that connection with a series of plates and give me the resulting 10-inch depth all the way across. And when we come over here, you'll also notice that 10-inch depth, it drops down, and then we have that 2-foot soffit here that we get to play with. And then we'll put that coffered ceiling in. Now we'll have the living room portion of this great room being able to be identified solely by the treatment that we're doing in the ceiling there. So that's one of the beauties of doing trusses, is that I can carve different volumes inside the truss, and the engineering at the truss company will resolve the engineering for those spaces, and I just give them the dimensions and we get trusses back like that. Another point to pay attention to here, notice we have our MyVest, and you're probably saying, okay, Steve, but this is an interior wall. It is, but it isn't, right? Notice up above here, we have our Zip R6. Now, this point here is where we have a 2-story portion of the house that sits against a 1-story portion. And remember from my videos on air barrier, you're either inside or outside. Well, this, when I fold this up, this is my air barrier. Anything below it is my air inside. Everything above it is outside. So this space in the attic, even though it's under roof, it's considered outside of my air barrier. So I need to connect that to my wall air barrier of the 2nd floor. So if you notice here, when I hold this up, I can see the Zip R6 underneath there. This first truss is not placed on the wall frame. The wall frame is sheathed with the R6, then this first truss is put up against it. And that way there, we can maintain that continuity of our air barrier. We can come down that wall, go across the ceiling, and down the wall to the foundation on the other side of the house. So let's jump upstairs. We got another neat little tidbit on the roof trusses that I want to talk to you about up there. So I'll see you upstairs. I got to go climb a ladder. All right, up the ladder to the 2nd floor. All right, so made our way up the 2nd floor. The things I do for you guys, climbing ladders. I know I'm like a cat. Let's just take a quick walk down here. Check this out. Yeah, look at these roof trusses. We got a about a 2-foot by 8-foot indent there. Now, I don't know if I told you, but one of the homeowners here, he's 7'6", and so we put the corridor down the middle of the house and we put the rooms on both sides so that he gets headroom. He's gonna have to duck to get into the rooms. If you know, I'm only kidding, right? Yeah, this is to see if you were paying attention. now that I got your attention. Now, so what's happening up here? We have our standard roof trusses. Like the living room, we have this 2 foot by, I think it's 8 foot, and then it drops down, and you can see goes across there. Now, our ceiling height in the room is going to continue across here. So you're probably wondering, what is that space and why do we care? So first of all, that space, let's just call it a plenum, because that's in fact what it is. It's an HVAC plenum. So we're on the second floor here. You know, you always have the option to put a unit downstairs, run a bunch of trunks up, trying to figure out how do we get them through the first floor and up here. Or in this case, if you remember from episode 1, when I gave you the tour of the second floor, right about where the camera is standing, there's a mechanical room. That mechanical room is going to have an upflow heat pump that is going to go in, and all of our ductwork is going to be in this plenum. So you can see here, this is that wall that right on the other side of this are the trusses to that great room. We just talked about it when I said let's go upstairs. This, in fact, if I cut a hole here, I'm looking into the attic of the first floor. But remember, the attic is a ventilated attic, so it's outside the building. So this is our air barrier. Air barrier comes up. There's that Siga MyVest detail where we have that membrane. That membrane is going to come across this bottom cord to this point, and it's going to stop. Inside this plenum, on the 2 sides, the top, and then the 2 ends, we're going to sheathe that with a 7/16 inch zip. We're not going to run the membrane in there. We're going to put zip in there. Why? When I was talking with Jim, he felt a lot more comfortable about putting a zip sheathing in there, because the HVAC guys, they're going to be pushing ductwork. They're going to need to be able to screw, nail things to, attach things to. The zip sheathing, while it provides an exceptional air barrier, also gives us a nail base, but it also provides the durability inside of that plenum. So as they're pushing and attaching stuff in there, they're not ripping the membrane. Jim's not trying to figure out how to go up and tape a tear that these guys did on top of the ductwork. We'll put that zip 7/16 in there. It'll come all the way to the end, and notice it stops right here. And then we go to our standard common trusses. The thing that we made sure of is, as we were doing this plenum, we wanted to make sure that the plenum caught every room on the second floor. So the mechanical room is probably somewhere right around here. And so that unit's going to go up, and we'll have ductwork in there. That plenum will feed every room on the second floor. And now, if you're going to, say, change filters, do any kind of maintenance, there's simply a door right here to the mechanical closet. You're going to walk in a nice little closet, and there's going to be an upflow heat pump here. So changing filters, doing maintenance, all of that. And remember, this house, aging in place, we don't want our homeowners to have to go get a stepladder, drag it upstairs, create a little 22 by 30 inch hole that they then have to climb over 22 inches of insulation to get at an air handler. Bad idea. Aging in place. We want the mechanical equipment where we know those filters are going to get changed on the maintenance cycle that they need it to be set on. So we're going to head back down the ladder. We're going to take a quick walk around the outside. There's a few pieces of the trusses there, some little tidbits that I want to share with you on the trusses. So I'll see you back down on the ground. All right, so hopefully you enjoyed that little trip up to the second floor. Take a little walk around. There's 3 different areas here down or on the outside of the building that I think are pretty important to talk about. And they talk to the versatility. You know, first of all, when you look at this roof truss system and you look down from a drone and you get to see it, it looks like just a very neat, organized system, and it pretty much is, right? Its goal is to really simplify the roof framing, and we have a whole bunch of little pieces that solve for things like valleys and such. Here we're going to have the front porch. You can see we have our piers there, stone, so we're going to have a little porch that gets built here. Our front door, we're going to have a little shed roof that comes off of here. So that little shed roof, that prompts us to alter the trusses just a little bit. You can see these trusses all the way down, those have that standard 24-inch tail that we talked about cutting. But notice from there over, there's a whole series of trusses there that are truncated literally at the heel height. And the reason for that is, well, we're going to have a flat ceiling and we're going to have a porch here, so we don't need those truss tails interfering with our framing on the porch. So those trusses get truncated, or basically cut, back at the wall frame so that we have this nice clean edge that we can then attach that porch roof to. Let's jump around the back side. I'll see you on the back of the house, and we'll talk about a couple more areas out back there. Made our way around to the back side. Notice we have a bunch of precast concrete piers buried, and notice we have this stone bed. We have our filter fabric there, so nothing will grow up. We won't get any weeds growing up. This whole area is going to be dedicated to a screened-in porch. Now, here in New England, screened-in porches are pretty much almost with every custom house we do, only because sun goes down in the summertime, mosquitoes flourish, and there's some that'll carry you away if you don't pay attention. But this isn't just your average screened-in porch. And by that, what I mean is we are going to have a deck that probably comes in somewhere up here, top of deck. On top of that, we'll have our 9-foot walls that'll hit that plate height. And then the ceiling here, this one isn't going to be trusses. The homeowners wanted this to be a beautiful volume ceiling with some kind of wood interior, you know, kind of cabin-like, if you will, so that when you come out to the screen-in porch, and we'll have a door right there that comes off of the kitchen and dining space. Episode 1, I walked through the plans, so don't tell me you don't know, because we talked about it. That'll bring these out to the screen-in porch, and you really want to have that give you a sense of departure, right? Like, if I'm going out to the screen-in porch, I want it to feel a little different than being inside my dining room and living room. So out here, it's going to be a little more rustic. We'll have that wood ceiling, but we're also going to have that volume ceiling. So it's actually going to trace that A-frame. This one, we're going to do what is termed a cut roof. We're going to conventionally frame it with 2x10s. But what that means is the trusses that we flew over the garage here, rather than carrying them through to a girder truss on the screen-in porch, that would have forced us to have that flat ceiling. Homeowner didn't want it, volume ceiling, so we take those trusses all the way back to this bearing wall, and notice it sits on the foundation there, so that goes up, and then those trusses just simply get truncated, and this roof will dive into that, and then that roof will come down and continue and create two valleys on the top of this roof. So we'll catch up with the framers when this is getting framed. This is our first day out here with the roof framing, so we'll come back and we'll catch up on that aspect. But again, I wanted to show you the versatility of having those roof trusses that we can literally pick any point on the truss and say, hey, let's cut that there. This one, notice, it flows into the pitch of the main roof there, and then we'll just have some infill framing. That's our screen-in porch. Let's jump around the corner here, and we'll finish our walk outside and talk about one last aspect of this roof truss roof. All right, so we just talked about that screen porch. Notice we have our piers here, and then it steps out. We have a pier there and a series there. So we're going to have an exterior deck here that's going to be exposed. We have our very large, and this windows actually gets cut back to here and probably down to here somewhere. So it's another 30% larger there. But the thing I want to call your attention to is notice that the wall comes here, dives back 3 feet, and then continues. Notice here we go down to the floor. with our flashing, and that'll get cut and detailed because we have a large lift and slide door here that's going to be basically the light to the living room, as well as our access out to the deck, which will be up here somewhere. Remember, one of the home's occupants is in a wheelchair all the time, perpetually, so we want to make sure that they can come out, experience the deck, enjoy the deck like anybody. So we're going to have that zero threshold here. So when I was thinking about this, the things that go through my mind: water, #1 killer of buildings. 2, lift and slide door, comes all the way down to the floor. If that thing leaks, it's going to damage the hardwood floors on the inside. 3, zero clearance. Outside deck is at the same height. Those 3 things should elevate your concern about this area. And what are we doing? So what I chose to do is, as we have this 3-foot dip here, going back from this face of the wall to here, notice our roof trusses up here. We have our 2-foot overhang. Here, they're maintained, but we get that additional 3 feet. So these are in fact 5 feet of overhang, right? And then that's going to come back to somewhere in here, which is maybe a few inches above the head of the door. And if you've seen some of my other videos, you've heard me talk about, I love to get a 2-to-1 ratio. 2 feet of overhang to, say, 1 foot of head distance between the top of the window and the bottom of the soffit. At a minimum, 1-to-1 I can live with, 2-to-1 is preferred. In this case, we are going to have 5-to-1. So I've exaggerated that overhang. Why? Because I'm severely concerned about the risk that we're imposing with this door here with a zero clearance lift and slide door. So when your problems get elevated, you can't keep your solutions down here. The solutions have to rise so that they're meeting the needs of that problem. And that's what we're doing here. So we'll see this a little bit more. You know, we're going to have a whole lot more video down here where you'll see this come to life, but I thought that was really important. And again, it's, when you look at this, it's just the versatility of the truss manufacturer to say, instead of putting our bearing point here, we'll move it 3 feet back. And let's say this is a 7 and 12, it just means that our heel height now grows 21 inches. Because we go back 3 feet, which means we go 3 times 7, 21. So our heel height increases 21 inches. And you can see the trussed heel height there is just much larger, but this whole roof over that area and this area stay in the same plane. So there you have it. Let's jump around front and we'll see if we can't catch a little bit of that roof sheathing going up. So let's see out there. All right, so we caught Ryan. He fired up the lull there, and you can see, you know, this is just a really quick example of what we would call flying the truss, right? We're getting it up into place. We have our rated strap there. We have our tag line here. The tag line is basically the rope, so we can get a guy on the ground to basically control it, and then we got some guys to receive it there. Notice they're all wearing hard hats for all of you OSHA agents out there that are watching. Shoreline takes safety extremely serious out here. Yeah, I'd love to tell you there's a lot of magic to it, but one of the beauties of trusses is it really simplifies the roof framing process, right? You end up with a structural member that is engineered to just what is required for the applied loads. And that's one of the beauties about the roof trusses are we could take this house and we can move it to different climate zones, and those roof truss designs would probably be altered a little bit, right? As you go north and you get a little more snow load, you would have to get a little bit stronger of a truss. As we move south, we might be able to change the engineering in that truss. And you can change the engineering by the metal connector plates, you can change the engineering by the size of the members, but you can also change the engineering by the quality of the members. So you can improve the strength of a truss by simply going to, say, a structurally rated member or a grade 1 2x4 instead of a grade 2 or stud grade. So there's ways that the engineers can play with those engineering numbers a little to satisfy the needs of the project. And like a lot of our projects, we have solar panels on the roof. So a lot of times we'll take those trusses and we'll add a little bit more to their performance to ensure that when we put the solar panels on the roof, that we're taking care of there. So let's head inside now and we'll take a look at some of the trusses that have already been set. All right, so I know I said we were going inside to talk, but as I keep walking, I keep seeing things and say, you know what? There's a little bit of a talking point here. So I wanted to just point this out. We just talked about the anatomy of a truss there. Now, that is your standard truss that's actually carrying roof load. There's other types of roof trusses like the one that you see below here in front of me. This is what we would term a gable end truss. Now, the reason I know that is, notice all of the web members are vertically oriented. They're not diagonal, doing what a typical truss does, moving the load across and basically treating the truss as a beam. In this case here, this truss isn't a beam. What it is it's a pre-manufactured end wall piece to the truss system. So that's why we call it the gable end. And if you notice, all of these are on the flat and they're 24 inches as they march against the truss. Now, all of the dimensions are dimensionally similar and compatible to the trusses that we've been flying. We have our slider, we have our 10-inch heel height, we have all of those dimensions. But because this truss is going to sit on the top plate at the end wall, it doesn't need to carry any load other than the cladding load and the last 8 inches or 12 inches of the roof system. So it's very, very minimal. This one is actually acting as a vertical gravity load, not as a beam like your typical truss. So that's the first half of roof framing. They set some trusses, we walked around, we talked a little bit about some of the specifics on trusses on the inside, the outside. As you can see, the gents are hard at it. They're starting to put down some of that roof sheathing. So why don't we let them take over, have at it. We'll return in a few days and we'll close out this whole episode on roof framing. So stay tuned. We'll be back in a few days. All right, so inside. Just so happen to have a handy dandy red stick. Yeah, how convenient, right? So we're talking roof framing. Roof trusses are in. Roof sheathing is up. As you saw on the outside, literally a minute ago, it's all shingled. So that means that we have to get ready for insulation and our air barrier. A couple things have to happen here. One, we have to get our baffles in. So this is a fully vented roof, right? So we have a eave vent down here at the bottom of the roof. The air goes up in back of these AccuVents, goes up into the attic, mixes with the attic air, and exhausts through a ridge vent on the top. Now, this AccuVent, you can see it here, and that is the trade name of this. So it's basically roof venting. It's made for the 24-inch spacing or the 22.5-inch cavity of a roof truss system. But notice it has this bendable flap. And so that allows you to basically put it up and you get this vertical surface here that is going to go on that raised heel part of the truss. And what we would typically do for a detail here is we are going to come in and we're just going to blow about 4 inches of closed cell by about 8 inches high and basically weld this vent into that truss space. It does a couple things. One, it ensures that we don't get wind washing. We don't want any air coming up and getting into our insulation. We want it going around the insulation and up the vent. So by putting in that closed cell, it kind of redirects and ensures that the air goes where I want it to go, not where the air wants to go. Plus, that 10-inch high heel with the closed cell, well, that's going to get us a quick R65 or so above that plate so that we are battling the ice damming effects of having little to no insulation there. We're going to have actually an abundance of insulation there. And then that becomes the backer for us to then blow our blown insulation or blown cellulose in this case up against it. So that'll kind of complete the eave. But these are kind of the whole sequence of events. And of course, they have to spray the closed cell. Then we'll take this MyVest, they'll fold this up, and they'll bring the Myrex across here, and the Myrex will complete the air barrier. But Jim had to go out of sequence and get the framing inspector over here to take a look at the whole roof, because in about a week or so, the Myrex will be across here, and the insulators will be working on getting some insulation up above that. I got 2 other stops before we close out this roof framing video, so why don't you just follow me over here. Earlier in the video, we talked about how these roof trusses had this recessed in them. Well, now that we've come back a couple weeks later, you can see Jim and the framers, we have our air barrier continuity happening up inside there. So inside of this large square, we're going to do a coffered ceiling. The homeowner wanted a way to architecturally delineate this as a living room within this larger great room. So we came up with this scheme of pushing up into the attic and providing a beautiful coffered ceiling. So can't wait for that to come, but you can see everything's intact. But this is a really, really good example of where the aesthetics of, say, a coffered ceiling meets the world of building science and air barrier continuity. Now, the last part that I wanted to show you, we'll take a walk here, is last time we were here, the roof to the screened-in porch was not installed yet. And it wasn't installed yet, if you remember, we had a bunch of truncated trusses here, but the homeowner wanted to go to a volume ceiling, which is vaulted, cathedralized, whatever you want to call it. I call it a volume ceiling, right? Basically, it goes up. So you can see in the screened-in porch here that we have that vaulted ceiling. The roof trusses actually stop on the other side of the zip R sheathing up here, and then we created that vaulted ceiling off the end there. So, but I think that's pretty much the complete talk about roof framing. Hopefully you enjoyed this video. Yeah, floor framing, wall framing, roof framing. Who doesn't love a great framing drawing, right? Yeah, so stay tuned though, because we have a lot of great stuff coming up here. We have some mechanical chases and such that are just a little bit out of the box thinking. So make sure you join us in the future. Greatly appreciate you watching the video, but I'm Steve Baczek, Architect. This is The Build Show, and that's roof framing for the forever.